So here are some examples of the different types of stoichiometry problems that you might encounter. The first is going from moles to mass, which is just about the simplest type of problem you can do. The only type that would be shorter would be moles to moles. That's the fewest step, mole to mole. The most steps would be mass to mass as far as these types of problems. So how many grams of water can be produced from 7.76 moles of NH3 ammonia? Well, since we have the moles, we're going to skip the first step, okay, because we were given moles. So we can put in 7.76 moles of NH3, and then the coefficients always come from the balanced equation up here. So the coefficient of our unknown, well, our unknown, how many grams of water? So water is the unknown with the coefficient of 6 up here in the equation, and ammonia is the known because that's what we were given, and the coefficient of ammonia is 4. So 7.76 times 6 over 4 is 11.64 moles. If we were asked for moles, we could stop here. But we were asked for mass, so the last step is to multiply the number of moles times the molar mass of the unknown. The unknown is water. The molar mass of water is 18 grams. It's 1 hydrogen and 2 oxygens. You look up those masses on the periodic table, add them together, you get 18. And when we multiply 11.64 by 18, we get 210 grams of water would be formed. Going from mass to mass. So this is one of the longer types of problems because we do have to start with mass over here in the very first box, and we're given 5.8 grams of O2. So we put 5.82 grams here, and then on the bottom goes the molar mass of what we were given. We were given O2. So since it's 2 oxygens, we would do 16 times 2, or 32, because each oxygen atom has a mass of 16. So 5.82 divided by 32 is 0.182 moles of oxygen. Then we go to our mole ratio in the middle. Our unknown here is the NO. It's always the one that follows the question, how many grams NO. Up here in the equation, NO has a coefficient of 4. And our known is the oxygen. That's what we were given. The oxygen has a coefficient of 5. So 0.182 times 4 over 5 is 0.146. And then we have to multiply, since we're looking for grams, we would multiply by that mass of NO. Nitrogen has a mass of 14, oxygen has a mass of 16. Add those together and you get 30. 0.146 times 30 is 4.38 grams. So that's what the question was asking for, and that's our answer. Another example of mass to mass. So we've got, we're back to the ammonia. How many grams of NH3? So that's our unknown. I'm going to mark that up there. To produce 10 grams of water. So this is another thing just to be aware of. It can be, the question can ask you any combination, any pair of items from the equation. So it's not always given this reactant, how much product. It could be given one reactant, how much of the other reactant do you need? Given this much product yielded, how much of the other product is also yielded, or any combination in between. So this time we're being asked to start with knowing that we want 10 grams of water. So we're starting over here with mass. The molar mass of water is 18. 10 divided by 18 is 0.556. The coefficients, our unknown is ammonia with a coefficient of 4. Our known is water, which has a coefficient of 6. So 0.556 times 4 over 6 is 0.371. And that's going to be times the mass of ammonia, which is 17, 14 for nitrogen plus 3 hydrogens. And 0.371 times 17 is 6.31 grams of ammonia would be needed to produce those 10 grams of water. All right, now we're going to go from mass, so we're starting in the same place as the last couple problems. The difference is we're ending with volume of a gas, so we'll get to that in a minute. But let's start off with our known. Our known is the 4.09 grams of ammonia, which, remember from the last problem, has a mass of 17. 4.09 divided by 17 is 0.241 moles. Our mole ratio, the unknown is liters of NO. So we want to look up here. That's our unknown is NO. And that has a coefficient of 4. And the ammonia is what we were given over here. The coefficient up here is also 4. So we've got 4 over 4. When we multiply 0.241 times 4 over 4, we get 0.241 again. Now here's the difference. In this case, we want volume. So instead of including the molar mass over here, we're going to include the molar volume of a gas at standard temperature and pressure, which is 22.4 liters for any gas. There's going to be another video that you can find that shows you all the possible variations of the stoichiometry map. So when do you use liters, when do you use molar mass, when do you use energy, when do you use 6.02 times 10 to the 23rd. So all that's explained in another video. But for now, we're going to find the liters of NO gas. So we multiply our 2.41 moles times the molar volume, which is 22.4, and we find that we would have 5.40 liters of nitrogen oxide. All right, so now we're going to go volume of a gas to volume of a gas. So the difference is we're still going to be starting over here in the first box, but we're doing volume now. So instead of grams of given, we're doing liters of given, 79.5 liters. The molar volume of any gas at STP, standard temperature and pressure, is 22.4. So 79.5 divided by 22.4 is 3.55 moles. Our unknown is oxygen. What volume of oxygen? So the coefficient there is 5. Our known is the ammonia, which has a coefficient of 4. So we do 3.55 times 5 over 4 is 4.44 moles of gas. And 1 mole of any gas at standard temperature and pressure is 22.4. So 4.44 times 22.4 is 99.5, and that's liters of gas. All right, so now we're going to go from atoms to mass, and we're still going to start in the first box. The difference is we're given 5.04 times 10 to the 24th, and instead of molar mass on the bottom, we're including how many molecules would be, or atoms would be, in any mole of anything, which is 6.02 times 10 to the 23rd. A little hard to read there, but it's 6.02 times 10 to the 23rd. So we divide 5.04 times 10 to the 24th by 6.02 times 10 to the 23rd, and we get 8.37 moles. Now from here, the rest of the problem is just like any other mass stoichiometry problem. We go our mole ratio, our unknown, how many grams of MgOH2. That's up here. It has a coefficient of 1. And we were given magnesium, which is up here in the problem by itself, also a coefficient of 1. So we have 8.37 moles of our unknown. And we do want mass in this problem, so we're going to go ahead with the molar mass of magnesium hydroxide, which is 58 grams. 8.37 times 58 is 485 grams. So G, grams of magnesium hydroxide. Going from mass to volume of a solid or liquid. Okay, so this is slightly different because we need to use density in order to solve this. We're going to start out like any other mass stoichiometry problem. We're given 10.27 grams of magnesium hydroxide, which we found in the last problem has a mass of 58. Divide those two numbers together and you get 0.1771 moles. Our unknown is magnesium, coefficient is 1. Our known is magnesium hydroxide, also a coefficient of 1 in the problem. So we've got 0.1771 moles of magnesium. Now, instead of, or no, actually, we are going to find the mass. So we're going to multiply by the molar mass of magnesium, which is 24 grams per mole. 0.1771 times 24 is 4.25 grams. Now the question, though, asks for the volume, and we're talking about magnesium up here, which is a solid. So we're not going to use the 22.4 because that only applies to gases. When you're dealing with a solid, we have to go back and remember that density equals mass divided by volume. We're trying to find the volume here. So if we rearrange the equation, volume is equal to mass divided by density. Well, I've got the mass here, we just found it. The density is given to me up here. So the volume equals 4.25 grams divided by 1.74 grams per cubic centimeter or milliliter, either one would work. We divide those two numbers and we find that the volume would equal 2.429 cubic centimeters. So that's the final answer down here. Alright, mass to heat. So we're talking about energy, which is always labeled as kilojoules in the equation. So in the equation here, you see 353 kilojoules. That's the amount of energy released during this reaction. So we're starting off with the mass again. So we're starting here in the first box. 10 grams of water divided by the molar mass of water, which is 18, and that's 0.556 moles. Now here's a difference in these energy problems. The coefficient of the unknown, our unknown is heat or energy. The coefficient is just the number of kilojoules that's in the equation. So in this case, the coefficient is 353. And the known was the water, which in this equation has a coefficient of 2. So 353 over 2, 0.556 times 353 over 2 is 98.1 kilojoules. Okay, so when you're doing energy, you can stop here, or heat. Either one of those two words are interchangeable as far as these problems go. So you'd stop here. You don't need any of this over here for an energy problem.